Hello and welcome to Unit 8 Opener number 1. We're going to be solving a system of equations by graphing. Before we get started with the graphing and the solving though, it's worth just mentioning a couple of big ideas before we start. First of all, since this is two equations, and it could be more than that, with the same variables, we call that a system of equations. Each one of these is a simultaneous equation. This also happens to be a linear system of equations, since both of the equations are linear. And when it says to solve the system of equations, what that means is to find the value or values of the variables that make all of the equations in the system true. In this case, these two equations, but there can be systems with more than two equations. So if you just look for a minute at the top equation, there's a whole lot of values of x and y that would make that equation true. For example, if we chose x to be 4, so if you can picture this x here being a 4, 5 times 4 would be 20, and then when you add 1, y would have to be equal to 21. All right, so that is a solution to the first equation. However, if we go now check that in the second equation, if we substitute a 4 in for the x here, so if we're putting a 4 there, 8 minus 2 times 4, that would be 8 minus 8, that would be 0. So 4, 21 is a solution to one of the equations, but it is not a solution to the system of equations. All right, so we need to find the point or points that make both of these equations true. And one way to do that is by graphing. So let me graph these two lines, and then let's see if we can make some sense out of them. Hopefully you remember that this looks like it's in slope-intercept form. That would be y equals mx plus b. So the y-intercept is 1, and the slope is 5. So I go up 5, 1, 2, 3, 4, 5 over 1, and up 5 over 1. And I can go the other direction too. I can go down 5 over 1. And I think I can fit one more point over 1 there. Oh, I can barely fit that point. Maybe I can't even fit that point. Let's see. 1, 2, 3, 4, 5, 1. All right. So here's our first line. I will graph this line in blue, and it looks like that. And remember, every point on that line, including the ones that I darkened in, but every point on that line makes the top equation true. Unfortunately, the point I used, 421, doesn't show up on this graph, but if we could see a little bit higher on the graph, 421 would be a point on that graph. All right, well, I'll do the second line in red, how about? So again, this one is in slope-intercept form, even though it's written just a little bit out of order. The slope is -2 and the y-intercept is 8, so I will start up here at 8, and then I'll go down 2 over 1, down 2 over 1, down 2 over 1. You'll notice I have already found the place where these two lines intersect each other, and as you may have guessed, that's an important point. Now if you picture this red line stretching off to infinity, in both directions, down this way and up that way. And then if you picture this blue line stretching off to infinity over here and down here, they will never again intersect each other. So this is the one and only place right here where those two lines intersect. Now if you remember that a point on the line is a point where the equation is true for that line or for that line, that means this point in the middle is the one and only place, this point of intersection is the one and only place where both equations will be true with the same values of the variables. And judging from my picture, which isn't quite perfect, the solution is 1, 6. So I'm just going to real quick check and make sure that does work. So I'll go back and I'll look at the top equation, and I'm going to substitute a 1 in here for x, so 5 times 1 plus 1. 5 times 1 is 5, plus 1 really is 6, so it works in the top equation. When x is 1, y is 6. And then I'm going to check it in the bottom equation. So that's 8 minus 2 times 1. 8 minus 2 is also 6. So when x is 1, y is 6. Both of the equations are true when x is equal to 1 and y is equal to 6. And so that is the solution to that system of equations. All right. I hope you enjoyed opener number 1.